Today we're going to be talking about section 2.4, which is on writing linear equations. So, linear equations can be written in many different forms, but one of which is called the slope-intercept form. Slope-intercept form is when you have some y is equal to m, which is our slope, times x plus b, the y-intercept, so where it crosses the y-axis on our graph. So if I look at example 1 here, it says to write an equation in slope-intercept form of this line. Well, if I look, I have 2 points. I have -4, -1, and 0, -2. So obviously, 0, -2, this is my y-intercept, which means that my b is going to be -2. If we know that b is -2, we can also find the slope to find what m is. Okay? Well, if we look right here, we have a rise or down of -1 and then a run of 4. So my slope is -1 over 4. Now, you could have done it the same way we've done in the last section where you took y2 minus y1 over x2 minus x1. Otherwise, this one works out the same way if you can just count it on the graph. So if we know m and we know b, we can see that our slope-intercept is y equals -1/4 x plus -2. We could also write it as -1/4 x minus 2 as well. Here's 2 guided practice problems that you can find now. We also have something called the point-slope form. And point-slope form is when you know a point and the slope, and you can put it into this. Point-slope form looks like this. Y minus y1 is equal to m, which is the slope, times the quantity x minus x1, where x1 and y1 is some point on the line. So if I look at this one right here, it says write an equation of a line through the point 6, -2 with a slope of -4. So that's going to be y minus, well, I go over here, this is my x1, my y1. So y minus a -2 is equal to the slope of -4 times x minus 6. Now the only critique I would say of doing it this way is that I have minus a negative. Looks kind of weird. So I can just change it to adding, and it's going to be y plus 2 is equal to -4 times the quantity x minus 6. Now notice, okay, it doesn't tell us it has to be in slope-intercept form. It doesn't tell us it has to be in standard form. It just tells us to write an equation of a line. And this is an acceptable equation for the line as well. Here's 2 guided practice problems that you can also try. Which is an equation of a line that passes through the point -2, 7, and 3, -3. So what we're going to do is we see we have 2 points. We see that all of our options, A, B, C, and D, are all in slope-intercept form. So what we have to do is A, first find the slope, and then from there we can put it in point-slope form to find out what it is in slope-intercept form. So first I'm going to find my slope. Okay, well the nice thing is I have 2 points, x1, y1, and x2, y2. Okay, so to find the slope, it's going to be -3 minus 7 all over 3 minus a -2. Okay, so -3 minus 7 is -10, and 3 plus 2 is 5. So -10 divided by 5, my slope is really -2. So right away, I can get rid of A, I can get rid of C, and for that matter, I can get rid of D. So my answer is going to be B. But let's say it's not that easy. Let's say we don't know for sure that it's going to be B. Well, if we know that we have the slope -2, and we can pick either one of these points. Let's say we pick the first point. We can put this in point-slope form. So it's going to be y minus 7 is equal to -2 times the quantity x minus a -2. Minus a negative, I changed it to adding 2. I hope that's okay. You didn't miss that. So now that I have this, I take -2 and I distribute it right here. So y minus 7 is equal to -2x minus 4. -2 times 2 would be -4. Then I'd add 7 to both sides. And I'd say y equals -2x plus 3, which in fact is D. So that's how we can go. We can go from finding the slope, then we pick either point. I could have picked the other point, 3, negative 3, and I'd get the same answer. Doesn't matter which point I pick because they're both on the same line. Here's a guided practice problem that you can try as well. Now, we have different types of lines. We have parallel and perpendicular lines. Parallel lines are kind of like railroad tracks. They go on forever, but they never touch each other. Okay? Just like on a railroad, if you have 2 points that, or 2 lines that cross, it'll be a mess. Okay? Perpendicular lines are 2 lines that intersect and they form a 90-degree angle. Now you'll notice some interesting things about their slopes. Parallel lines have the same slope of 2. Okay? Both of them have the same slope. Perpendicular lines have a slope of 3 and negative 1/3. So we remember that perpendicular slopes are opposite reciprocals of each other. Okay? Opposite reciprocals of each other. So if I look at example 4 here, it says, write an equation in slope-intercept form of a line that passes through 5, negative 6, and is perpendicular to the line with this equation, y equals negative 3 halves x plus 7. So the first thing I'm going to do is to say, okay, well this is perpendicular, which means my slope has to be the opposite reciprocal of this example right here. Well, since the slope is negative 3 halves, the slope of my perpendicular line is going to be opposite, which would mean positive, and reciprocal would be 2/3. Okay, so the slope of my new line is 2/3. And then I know it passes through the point 5, negative 6. So what I can do is I can put it into point slope form. And I'd say y minus a negative 6 is equal to 2/3 times x minus 5. Okay? So I take 2/3 and I multiply it by everything inside the parentheses. So y, we make this plus 6, is equal to 2/3 x minus, and for sake of easiness, I'll just keep this as 10/3. Okay? 2/3 times 5 is 10/3. Now, I have to get rid of this minus 6, and I'm subtracting 6. Now, you might be confused at what 6 is when it's over 3. Remember, 6 is 6 over 1. So if I wanted to have the bottom be 3, I'd have to multiply the top by 3. So that would be 18/3. So now I actually have something that's going to make a little bit more sense. So I'd be left with y equals 2/3 x, and then negative 10/3 minus 18/3 would be negative 28/3. And I can leave it just like that, and it will be correct. Here's a guided practice problem that you can try also.